Hi guys, Dr. Diaz here again. Look at this problem. Another problem for the review and the homework. This one says a tank holds a layer of oil 1.5 meter thick, which floats on a layer of syrup, which is 0.66 meters thick, and both liquids are clear and do not intermix. Well, okay. A ray which originated at the bottom of the tank on the vertical axis crosses the oil syrup and interface with a 90 degree, like it says here. You see the tank? This is the oil. This is the syrup. Here comes the angle. I mean the ray, and it crosses 90 with a point 90 from the horizontal here. I mean the vertical here. That's what it says. Vertical, and then the ray continues and arrives at the oil-air interface at 2 meters away from this vertical, and it goes then at critical angle. And they're asking you what's the index of refraction of the syrup. So this kind of problem, you have to start from the bottom and goes all the way up to find the index of refraction. Basically, what we're finding is we need to find a lot of stuff here, but the first thing we're going to do is find the index of refraction of oil, and then we go back and then find the index of refraction of syrup. And we know the air is going to be 1, and we know that the air with the interfaces goes at critical. So things we need to know was the angle of the syrup. Let me put it here. Okay, and I already wrote here the angle for the syrup, oil, and air. And I'm making this already this diagram here, which actually is this part here, right? You see the centimeter, 0.66 meter high. The ray will deviate from this vertical, which is 0.90 meters. And for us, our interest will be this angle. This angle we call theta oil, which actually then later is going to be equal to this one, which is going to be easy. And later on, we will start finding the index of refraction of the syrup. We need to know those angles. Okay, but let's put it here so we know this angle we're going to find. So the first thing we're going to do is find this angle of theta s, the one for the syrup. And if you remember this one, you have here the size adjacent, and this one the side that is opposed to the angle. So the way where we can find this angle is by using tangent, because you remember tangent of that angle is equal to what? Oppose over the adjacent, which in this case the opposed size is going to be what? 0.9 divided by 0.66. So in order to find the angle, you use tangent inverse of 0.90. Oh, it's 90, I'm sorry. Divided by 66, 0.66. And if you do that, your answer is going to be 53.7 degrees. Okay, let's put it here. 53.7 degrees. Okay, good. Now what about the angle for oil? Because we need all of these in order to find, use then Snell's law. Well, if we go here, this position here, well, we have the height again, which is going to be 0.58, and like let me see if I can do well. Probably you can see here what I'm doing. You see this thing? We have the height here, which is 0.58, right? This number here, and we have here from here to where these right intersects here 2 meters, but we know that from here to here is 0.90. So then we have what? 2 minus 0.9. That's the distance that we're going to use here. 1.1. I can barely see this one. 1.1 meter. So in order to find theta, we're going to use the same procedure. Tangent is going to be equal to opposed divided by adjacent. Here the opposed will be the 1.1, which actually in the diagram looks much smaller than the 0.90. But again, this is the diagram. Come on, guys. Okay, we're using the real number. It's going to be 1.1 divided. Well, it's going to be tangent is going to be here. Let me write it here, the whole thing again. Because here we go. Tangent of the angle theta oil is going to be the opposed divided by the adjacent, which in this case is going to be the opposed is 1.1, which is the difference between 2 and minus 0.90, divided by the height, which in this case is 1.58. And then we do the same thing. We find tangent of oil, the angle of oil, which is going to be tangent inverse of 1.1 divided by 1.58. And if you do this, we're going to get 32.6 degrees. Okay, now we have all these angles. We have for 0 at 53.7, for oil 32.6. Now let's go to find the index of refraction of oil. I'm going to move this a little bit down. Oops, but I forget something. We haven't found the angle for the air, but it doesn't matter. But because the problem says that the angle of air is at critical, we know that this angle is going to be 90 degrees. Yeah, and sine in this case is going to be easy because sine of 90 is going to be 1. Right? So, in order to calculate the index of refraction of oil, then, well, let's find n naught. In order to calculate the index of refraction of oil, we use Snell's law again. And this one would be index of refraction of oil. Sine of the angle of oil is going to be index of refraction of air. Sine of the angle of air. But the good thing that the angle of air is going to be 1. I mean, this is going to be 1 because sine of a naught, which is, I'll put it a naught, it could be theta a naught. Yeah, actually, I should write it like that. Let me rearrange this, fix this. Yeah, I change here the angle. And since theta is equal to 90, sine of 90 is equal to 1, so we know that this part is going to be just index of refraction of oil, sine, I'm sorry, let me arrange this again. Yeah, I was going to put equal, let's put sine of theta, air is going to be the index of refraction. Now, solving for the index of refraction of oil, this is going to be what? Na is equal divided by sine of theta oil. This is going to be what? Air is 1. The index of refraction of air is 1. Sine of the angle. Sorry, I have to move up and try to find the angle. It's 32.6. And if we do this, it's going to give us 1.86. So the index of refraction of oil is 1.86. Now that we have the index of refraction of oil, we already know that the index of refraction of air is 1. Let's calculate the index of refraction of the syrup, which actually was the problem was looking for. So using Snell's law again, we have the index of refraction of the syrup. Sine of the angle of the syrup is going to be equal to the index of refraction of oil, sine of the angle of oil. The good thing is we have everything except for this the index of refraction of the syrup, which actually is what we're looking for. So it's going to be NS is equal to what? N oil, sine of the angle of oil, divided by the sine of the angle of the syrup, which is going to be N oil is 1.86 times sine of the angle of oil, which we did a moment ago, is 32.6, divided by sine of the angle of the syrup, which it was over here. It was 53.7, and if we do this calculation, we're going to get that the index of refraction of this syrup is going to be 1.24. Voila, there it is. Okay, guys, I hope this helped a little bit. Remember, look what we did here. We go back to the problem. Let's see, we have a few seconds here. The first thing is we establish all the angles we're gonna need to. We use a little bit of trigonometry here. We use tangent inverse, and we get the angles. Once we have the angles, we start finding. And remember, there's one that's given, which is here is 90 degrees. We start finding what? First, the index of refraction of oil, and then after oil, we're gonna find the index of refraction of the syrup, which is what we're looking for. Okay, and then at the end we get 1.42. Okay, guys, I hope this helped a little bit. Just look at the video a couple of times until you get it. Take care. Bye.